Hey everyone, and welcome back to the channel. Today we re-diving deep into a topic that's as fascinating as it is powerful, the meticulous engineering behind modern ordnance. This video is purely for educational purposes, aiming to shed light on the incredible precision and science involved in manufacturing these devices. So let's explore how they are transformed into highly controlled tools. Our journey begins with the casing. It all starts with high-strength steel alloy, chosen for its ability to withstand immense pressure before fragmenting in a predictable way. Huge billets of this specialized steel are heated until they glow bright orange, making them malleable. They're then forged and pressed into the iconic aerodynamic shape. This isn't just about looks. The shape is crucial for stability during flight. After forging, the rough casings are sent to precision lathes. Computer-controlled machines meticulously interior and exterior, ensuring every millimeter meets exact specifications for wall thickness and balance. This precision is key to the device's performance and safety. Next, let's talk about what goes inside. The main explosive charge is often a stable compound like TNT or a plastic-bonded explosive. These materials are known as seconds, meaning they are remarkably stable under normal conditions. You could hit them with a hammer or set them on fire, and they generally won't detonate. This stability is a critical safety feature. The explosive material is usually melted and carefully poured into the finished casing in a process that looks a bit like filling a candle mold. It's done under strictly controlled temperature, any air bubbles which could affect the detonation wave. Once filled, the mixture cools and solidifies, becoming a solid, stable block inside the steel shell. But how does this stable block of explosive actually detonate? This is where the fuse and the booster come in. The fuse is the brain of the device. It's an incredibly sophisticated piece containing sensors, timers, and a small primary explosive. Primary explosives are much more sensitive than the main charge. The fuse decides when the device should detonate, could be on impact, after a certain time, or at a specific altitude. When the fuse receives its signal, it triggers a small detonator. This sets off a slightly larger, intermediate explosive charge called a booster. The booster's job is to create a shock wave powerful enough to initiate the main, stable explosive filling the casing. This multi-step process, from fuse to booster to main charge, is a safety chain that prevents accidental detonation. Finally, assembly and quality control. In the final stages, the fuse assembly is carefully installed into the body of the device. Fins are attached to the tail to provide stability and ensure it flies true to its target. Every single component, from the smallest screw in the fuse casing, undergoes rigorous testing. This includes X-rays to check for internal flaws, pressure tests, and electronic diagnostics for the fuse. Only after passing dozens of quality checks is the device considered complete. From a simple piece of steel to a complex instrument power, the process is a masterclass in chemistry, metallurgy, and precision engineering. The science behind it highlights the importance of control and safety at every single step. Thanks for joining us on this educational deep dive. If you found this interesting, be sure to like, subscribe, and hit the bell for more. See you in the next one.